Today we have a copy of Pokémon Ruby that is refusing to boot. If we try to play it, we're met with a white screen, and that's it. Let's first start with the basics. We'll use an eraser pencil to clean up the contacts, and as you can see, it's taking off a lot of top layer grime, but I'm not really sure if that's all this cart needs. And it's still not booting, but I'm not giving up that easy. Next, we'll resolder every joint on the PCB to roll out a cold solder joint. First we have to remove the dead battery, then we can load up every joint with some flux and remove all the old solder using wick. You could just reflow the old solder and see the same results, but I prefer adding fresh solder. When using wick, it's important to go with the lead and use very light pressure. You shouldn't have to press down hard for proper heat transfer. Flux in a tin tipped also helps. Now we can resolder all the chips. I personally like adding solder pin by pin so that I can better control the flow of it, but I still use the drag method from time to time. And just for good measure, let's resolder all the smaller components as well. Let's see if all of that paid off. We made some progress, but it's still not booting, so let's go ahead and clean off all that flux and give it another shot. The game is now recognizable, but it's still not booting, so now we're hunting for a broken trace. To do this, I'll use my multimeter set to continuity mode and rank the pins of the chips with one lead while the other lead is on a pad. A beep means that the pad has continuity and therefore is good. This pad is giving me no beeps. I think we may have found the culprit. Under the scope you can see that the pad leads to a corroded via, and this would explain why we're not seeing continuity. We'll have to repair this broken trace by first removing some solder mask above the pad to create a through-hole solder pad for 30 gauge wire. The 30 gauge wire can now be fed through both holes and continued on the other side. The solder mask on the bottom trace has to be removed in order to create a solder point. Now we can solder both ends of the wire with the help of some flux. Now it's time to clean it up and see if it works. So this is probably the 8th time plugging this cart in. Let's see if we finally fixed it. Just one broken trace, and who knows, maybe a cold solder joint or two. All of the solder joints on this PCB are completely fresh. Everything has brand new solder on it, and that broken trace is repaired, as I wasn't getting any continuity on it. So let's go ahead and put the game back inside the case and plug it into Game Boy Macro. Turn it on. Alright, so that's a good sign. Half the time when I booted this game, it would just go to a white screen on this and hang there. And every once in a while, it would get this, and then it would hang after the Game Boy screen. It would hang right after this. So, moment of truth. Alright, and there we go. Awesome, so it is working. It's just that one broken trace and possibly a cold solder joint or two. Alright, cool. Now I'll try to source a replacement battery before I send this back. This one is reading way under 1 volt. It's supposed to be 3, I believe, so it's not going to do anything inside the cart. But I did remove it and clean up the pads for the user to install a fresh battery if I can't find one before sending this out. That's it for this video. Thank you guys so much for watching. Leave a comment below, subscribe if you'd like, and I would see you next time.